All right, let's do problem 17 on page 731 in chapter 23. Here's the problem. Ugh. Wait, is that on camera? Good, yeah. And number 17 is right here. It says 2-point charges are located on the x-axis. The first is a charge of positive q and at x equals negative a. The second is at an unknown charge located at x equals 3a, positive 3a. The net electric field these charges produce at the origin is a magnitude of 2k q over a squared. What are the two possible values of the unknown charge? So let's take a look. I drew the x-axis, and here's our origin. Here's 1a, 2a, 3a. So here's our unknown charge. And then here's positive q here. But then right here, we know what the electric field is. But here's the deal with this. It gave us the magnitude, but it didn't give us the direction. There's two possible directions, right? To the left or to the right. And that's why there's two answers, because the electric field is a vector. So, let's solve this. If we want to know the electric field right here, it's going to be equal to the electric field due to this point charge plus the electric field due to this point charge. So let's go K Q over A squared, right? And this is positive charge, so this is going to be in the positive I hat direction. Now, one of the things, I'll get to that in a minute. All right, then we're going to add to that the charge from this guy. And let's say that it's a negative charge. If Q is a negative charge, if this little q right here is a negative charge, then it's going to attract whatever positive test charge I put at the origin. So we'll do that. We'll go K Q over 3A squared in the I hat direction is going to be equal to E, which is 2KQ over A squared. And we're going to say that that's going to be in the positive I hat direction as well. So the first thing I can do is just not worry about everything's to the right. I don't need to. So now we can solve for Q. So one of the things I can do is get rid of the I hat, get rid of K. I can get rid of A squared. And so I'm left with Q plus Q over 9 equals 2Q. And so then I can subtract a Q from there. And I get Q over 9 equals Q. So Q equals 9 times Q. But we said in order to make this in the positive I hat direction, we assume that this Q is negative, right? So Q is actually going to be equal to negative 9 times Q. So that's the first answer. Now the second answer, we're going to set it up the same way, but now we're going to say that it's to the left. So this is going to be the same. This is still going to be KQ. Oh, no, because this is positive Q, so no matter what, it's going to be to the right. So this is going to be KQ over A squared in the I hat direction. Plus, now, in order for this to be to the left, this charge the electric field from this point charge also has to be to the left. So we're going to make that a positive charge. But the direction of it, so we're going to go KQ over 3A squared, but that's going to be in the negative I hat direction. And then that's going to be equal to, now we just said that this right here is going to be to the left. So it's going to be 2KQ over A squared in the negative I hat direction. So when we add these two together, we're going to get that. So again, just like the last thing, we can cancel out the K's. And we can cancel out the A's. And so we can cancel out the I's, but you're not canceling out those negatives. So we have a Q plus Q over 9, but oh, it's minus because of this negative from there. So minus Q over 9, and that's going to be equal to, let's see, to 2Q, to negative 2Q, right? Because we got the negative from that. So we're going to subtract Q from both sides. So we get negative Q over 9. Got to make sure I keep my 9's and my Q's straight. So that's negative, and that's going to be equal to, well, this would be, if I subtract a Q from that, it'd be minus 3Q, right? And so now I'm going to multiply both sides by negative 9. And I get Q is equal to, well, negative 3 times negative 9 is 27 times Q. And it is positive. We stipulated before that because we're making this negative I hat, that is, the electric field from this charge is pushing our test charge to the left. That's why, that can only happen if this is a positive charge. And there we go. That's how I did it. Any questions? Yes?
Why is it that in the first part you have to, the math didn't come out right and we had to switch the sign, but the second part you didn't have to switch the sign?
Well, the question is, how come the math didn't come out with the correct sign? Well, that's because I put the sign of the charge in there by assuming that the electric field was to the right. And so remember, the sign of the charge, whether it's positive charge or negative charge, the sign of the charge is really only what effect it has, that sign, is to determine the direction of the electric field at the origin. And so so if you say, hey, this charge is negative, then this will be in the positive I hat. So so you've already assigned by the vector nature of it, you've already said that it's negative charge. So here we're just solving for the magnitude of that negative charge, but you just put the negative in there at the end. I think that, I don't know if there's a way to do it otherwise. If you put the negative in there, the negative charge in there, I think, yeah, it will mess up your math, definitely. Okay, that is all.